let's go ahead and begin our discussion on formal charge. So for formal charge, what we're going to do is we're going to compare the number of valence electrons around the species, or the molecule here, and compare it to what would occur in the isolated atom. So the way that we calculate the formal charge, which I've abbreviated FC here, is you take the number of valence electrons from the isolated species, so a Lewis symbol like we have here, or here, and then you would subtract off the number of valence electrons that are found in the molecule. So let's go ahead and consider, for example, HF. Okay, so we've already drawn this Lewis structure before. So let's go ahead and look at this. So for the formal charge for hydrogen. All right, so how many valence electrons are in the isolated species? Well, hydrogen has 1. Okay, so then whenever we are going through and trying to figure out how many valence electrons there are in the molecular compound, we have to be careful because we count the electrons in 2 different ways. If you have a lone pair, okay, so that counts as 2 electrons. But if you have a bond or a bonding pair of electrons, this counts as half, so this only counts as 1 electron. So if we were to look at hydrogen up here, so keep in mind that these electrons right here are bonded, okay, so they're bonding hydrogen and fluorine together, so that would count as 1. So we would have 1 minus 1 for a formal charge of 0. Okay, so let's go ahead and consider fluorine. So the formal charge on fluorine, so what we'd do is we'd first say, okay, well, how many valence electrons are in the isolated species of fluorine? So we'd say there's 7 valence electrons. Now how many are in our bonded species up here? Well, we count each of these lone pairs up here as 2 electrons. So we have 2, 4, 6 electrons from lone pairs. And then from that bonding pair of electrons, that only counts as 1, so that's a total of 7. So in this case, the formal charge on fluorine is 0. So this was a nice case, and many times the formal charge will be 0. But let's go ahead and look at a case where we might actually have a formal charge. Okay, so let's write a Lewis structure for NH4+, the ammonium ion, and assign a formal charge to all of the atoms. All right, so the first thing we want to do is figure out how many valence electrons do we have. Okay, well, nitrogen has 5. Then we have 4 hydrogens, each with 1, so that's plus 4. But then since there's a positive charge, that means we're actually going to be losing an electron. So we would subtract 1 off. So 9 plus 4 minus 1 is equal to 8. So what you really want to watch for here is anytime you're calculating the number of valence electrons, it should always come out to be an even number, especially at this level. So now let's go ahead and try to draw our Lewis structure. So we have a total of 8 valence electrons. So if we look at this, we have nitrogen, which has 5. And then we have hydrogens, each with 1. So this will take a little bit of practice, and eventually I'm going to show you what may be considered an easier method for going through, especially whenever you have a charge or a multiple bond. But right now, if we take away a valence electron, since we're losing an electron, let's take it away from nitrogen. Because as soon as we do that, what we'll see is that each of the hydrogens can come in and share an electron with nitrogen. And then nitrogen will have a completed octet, hydrogen will have its outer orbitals fill, and then this is a good Lewis structure, so we've accounted for all the valence electrons. So now we need to go through and assign formal charges. So as we look at this, again, recall that hydrogen is supposed to have 1 valence electron. So the formal charge around hydrogen, we'd say, okay, well, each one is supposed to have 1. And then since we have these bonding pairs here, we only count the bonds as one electron for formal charge. So we would have 1 minus 1. So the formal charge on all the hydrogens is 0. Now if we were to go through and calculate the formal charge for nitrogen, the Lewis symbol for nitrogen, it has 5 valence electrons, but here there are 4 bonding pairs, and remember we count the bonding pairs as 1 each, so we have 5 minus 4, so the formal charge on nitrogen is actually plus 1, and so we would just write that over here by nitrogen. So a really important point to make right now is that whenever you're going through and trying to figure out whether something obeys the octet rule or if it has a formal charge, so if you're looking at the octet rule, okay, octet rule, we would have bonding pairs or bonds. Those count as 2 electrons. But if you're looking at the formal charge, then the bonds, they only count as 1 valence electron. So make sure whenever you're trying to check to see whether something obeys the octet rule or if it has a formal charge, that you keep that in mind. So we aren't quite done yet because we have to indicate that there is a charge on this species, and there's 2 ways of doing this. So one of the ways is to put this whole thing in brackets, and then we put the plus 1 charge up here. So sometimes you won't even see the plus 1 charge written by the nitrogen, it just might show the overall charge up here. But the shortcut way that we'll tend to use as we go on is we'll have our Lewis structure here. And then instead of drawing both sets of brackets, we'll draw the top right corner and then put the charge, which is plus 1. So this should not be considered with that, confused that there's a 7 plus charge on the ammonium. This is the top right corner, and then this is a plus 1 charge. Okay, so make sure you don't get that confused. So we'll use formal charge more and more as we go on with looking at drawing these Lewis structures with a skeletal method. But so next time what we'll do is we'll start to look at multiple bonds and then some of the effects that the multiple bonds have on the molecules.